The National Electrical Code, or NEC, provides guidelines for connecting a lightning protection system to the main electrical ground. According to Section 250.145, the grounding electrode system must be connected to the lightning protection system as specified in Section 800.40. This connection is crucial for safety, ensuring that lightning strikes are safely conducted to the earth, minimizing the risk of damage to the structure and protecting individuals inside. Section 250.104 focuses on bonding of piping systems and exposed structural metal. Subsection A specifically deals with metal water piping. In dwelling units, metal water piping systems, and exposed structural metal that are likely to become energized must be bonded to the grounding electrode system. The bonding jumper must be sized according to Table 250.102 cone, with certain exceptions. The bonding point should be accessible. For other buildings or structures, metal water piping systems that are likely to become energized shall be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor, or the one or more grounding electrodes used. The bonding jumper should be sized in accordance with Table 250.102 cone and accessible. Exposed structural metal that is interconnected to form a metal building frame and is not intentionally used as an equipment grounding conductor or grounding electrode shall be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor, or the one or more grounding electrodes used. The bonding jumper shall be sized in accordance with Table 250.102 cone. Metal gas piping must be bonded to the grounding electrode system if it's likely to become energized. The bonding jumper shall be sized according to Table 250.102 cone. Other metal piping systems or metallic objects that are likely to become energized shall be bonded to the grounding electrode system or to one or more of the following: 1. The service equipment enclosure. Secondly, the grounded conductor at the service location. Thirdly, the grounding electrode conductor, if of sufficient size. Fourthly, one or more grounding electrodes used. The bonding jumper shall be sized in accordance with Table 250.102 cone. Section 800.40 provides details about the installation requirements for lightning protection systems. The main focus of this section is on protecting communication systems from lightning strikes. Communication cables, such as telephone and data cables, can act as pathways for lightning surges to enter a building, potentially damaging equipment and endangering people. Section 800.40 covers the general requirements for the protection of communications equipment. The metallic sheath of communications cables entering a building must be grounded as close as practicable to the point of entrance. This grounding helps to divert lightning surges away from sensitive electronic equipment. Section 800.40b details the protection requirements for the primary protector. A primary protector is a device designed to limit overvoltages on communications circuits. It must be listed for the purpose and installed in accordance with its listing. The primary protector must be located as close as practicable to the point where the communications cable enters the building. Section 800.40c discusses the grounding conductor. The grounding conductor for the primary protector must be insulated, copper or other corrosion-resistant conductive material, stranded or solid, and not smaller than 14 AWG. It must be run in as straight a line as practicable from the protector to the grounding electrode. The grounding conductor must be securely fastened to the building structure. Section 800.40d addresses the bonding of electrodes. The grounding electrode for the communications system must be bonded to the building's grounding electrode system. This bonding ensures that all grounding systems are at the same potential, minimizing the risk of voltage differences that could cause damage or injury. The bonding conductor must be sized in accordance with Table 250.102 cone. Specific instructions for bonding to different types of electrodes are provided. If a ground rod is used, it must be located as close as practicable to the point where the communications cable enters the building. If the building has a metal water pipe grounding electrode, the communications grounding conductor must be bonded to the water pipe within 5 feet of the point where the water pipe enters the building. If the building has a concrete encased electrode, the communications grounding conductor must be bonded to the reinforcing steel of the concrete encased electrode. If the building has a ground ring, the communications grounding conductor must be bonded to the ground ring. The connection between the lightning protection system and the electrical grounding system is critical for ensuring safety. Lightning strikes can generate immense amounts of energy, and if this energy is not properly diverted to the earth, it can cause fires, explosions, and other serious hazards. By connecting the lightning protection system to the electrical grounding system, a low impedance path is provided for the lightning energy to flow to the earth. This helps to minimize the voltage rise within the building and reduces the risk of damage to equipment and injury to people. The NEC provides specific requirements for the size and type of conductors used for grounding and bonding. These requirements are based on the amount of current that the conductors are expected to carry. It is important to follow these requirements carefully to ensure that the grounding system is capable of handling the energy from a lightning strike. The NEC also provides requirements for the installation of grounding electrodes. Grounding electrodes are devices that are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. The NEC specifies the minimum size and depth of grounding electrodes, as well as the spacing between multiple electrodes. In addition to the NEC requirements, there may be local codes and regulations that govern the installation of lightning protection systems. It is important to check with the local authorities to ensure that the installation complies with all applicable requirements. A qualified electrician or lightning protection contractor should perform the installation of a lightning protection system. These professionals have the knowledge and experience to ensure that the system is installed correctly and that it meets all applicable codes and regulations. Regular inspection and maintenance of lightning protection systems are essential to ensure that they are functioning properly. The system should be inspected at least once a year, and any damage or deterioration should be repaired promptly. The connections between the lightning protection system and the electrical grounding system should be checked to ensure that they are tight and corrosion-free. By following these guidelines, one can ensure that the lightning protection system is properly connected to the electrical grounding system, providing a safe and effective means of protecting the structure and its occupants from the hazards of lightning strikes. Lightning protection systems are designed to intercept lightning strikes and safely conduct the energy to the ground. These systems typically consist of air terminals, also known as lightning rods, which are installed on the roof of the building. The air terminals are connected to a network of conductors that run down the sides of the building to grounding electrodes buried in the earth. When lightning strikes an air terminal, the energy is safely conducted through the conductors to the grounding electrodes, where it is dissipated into the earth. The grounding electrode system plays a crucial role in the effectiveness of a lightning protection system. The grounding electrode system must provide a low impedance path for the lightning energy to flow to the earth. This helps to minimize the voltage rise within the building and reduces the risk of damage to equipment and injury to people. The NEC specifies the requirements for the grounding electrode system, including the size and type of grounding electrodes, the spacing between multiple electrodes, and the connection between the grounding electrode system and the building's electrical system. In addition to the NEC requirements, there may be other applicable standards and guidelines for the installation of lightning protection systems. These standards and guidelines may provide additional information on the design, installation, and maintenance of lightning protection systems. It is important to consult with a qualified lightning protection contractor to ensure that the lightning protection system is designed and installed in accordance with all applicable requirements. The connection of a lightning protection system to the main electrical ground is a critical safety measure that helps to protect buildings and their occupants from the hazards of lightning strikes. By following the NEC requirements and other applicable standards and guidelines, one can ensure that the lightning protection system is properly installed and maintained, providing a safe and effective means of protecting against lightning damage. Section 250.104 specifically emphasizes the importance of integrating the lightning protection system with the overall grounding infrastructure of the building. This integration ensures that any lightning strike is effectively channeled to the earth, preventing potential hazards. Section 800.40 elaborates on the specifics of grounding communication systems, which is vital because these systems can act as conduits for lightning surges. Grounding the metallic sheaths of communication cables helps to divert these surges, safeguarding sensitive electronic equipment. The grounding conductor must meet certain specifications in terms of insulation material and size, as outlined in Section 800.40c. It should also be run in a straight line to the grounding electrode for optimal performance. Bonding electrodes, as covered in Section 800.40d, is essential for maintaining equipotentiality. This means ensuring that all grounding systems are at the same electrical potential, which minimizes the risk of voltage differences that could lead to damage or injury. The location of the grounding electrode is also a crucial factor. It should be as close as possible to the point where the communication cable enters the building to provide the most effective protection. Proper grounding and bonding are critical for mitigating the risks associated with lightning strikes. By adhering to the NEC guidelines and employing qualified professionals, buildings can be effectively protected against lightning damage.